Hi guys, this is a quick reminder about some trigonometry identities that you need to learn, and unfortunately it looks like some of you don't have much experience with this, so I hope I'm going to talk to this quickly, and basically I'm just going to say whatever we need, and that's it. So everything starts with the right triangle. Okay, the right triangle is the one that it has two sides that forms a 90-degree angle and a hypotenuse. Okay, so this triangle has we know that it has, of course, three angles, and that one of them is 90 degrees. The opposite one to the 90 degrees is called the hypotenuse. Okay, so then we always define one angle like this theta, and once we have this angle, we can define one side as the opposite side, and then we have the adjacent side. Okay, if this angle is in here, well, just like the spring here, if this angle is this one, then this is going to be the opposite side, and this is going to be the adjacent side. Okay, so now you have these relationships, like what is the sine is the opposite side divided by the hypotenuse, the cosine is the adjacent side divided by the hypotenuse, and the tangent is the opposite and divided by the adjacent. Okay, you have it here. Okay, so this is you can describe the tangent also you can write it down as sine over cosine. Okay, then you have the what is the inverse of the sine and the cosine, but we don't need that. You can learn this. I'm going to give you this how I call that, this link. I'm going to post it in the comments of this video, so you can come here and check. Now this is one of the important relations we have, is sine square plus cosine square equal 1. This is one of the things we use. This comes from how to compute the hypotenuse, having the a and b, the sides, a squared plus b squared equals c squared. So if you divide by c squared all of them, you have sines and cosines. Okay, so yeah, so from this, if you move this here, you have the sine squared is equal to 1 minus cosine squared, and this is the things also you need to remember. This is also very important. So the sine, that what is the minus angle, is equal to minus the sine. And to remember this is sometimes I don't remember like this. Usually the best way is check the unit circle. The unit circle is this guy here. This you can also play around with this, and in here you have the angle and how it looks like. This is a circle with the radius is equal to 1. Okay, so you have in here in the first quadrant, which is from 0 to 90 degrees, you have all the angles, and you can see how the sine and the cosine varies with the angle. Okay, so this angle is let's see if I can, this you have 30 here, and you can see that the sine and the cosine is positive. If I say the angle like minus 30 is this one, 300, this one is minus 30, and you have the cosine is the same sign, but the sine is negative. In here you have like, what is this, 30, so 150. The sine is the same, is positive, but the cosine is negative. And in here 200, 110, and here it is, the cosine and the sine are negative. Okay, so you can play around with this, and you can see how this angle changes. Okay. Another thing that is also important is this double double angle identities, like the sine of 2 theta is equals 2 times the sine theta cosine theta, and this is also interesting. The cosine of 2 theta is equals cosine square of theta minus sine square of theta. Those sometimes we use them, and yeah, these two, but well, they're not as we don't use it that often. Okay. Another important rule is the complementary, what is called the complementary angles. So if you have here, you have this right right triangle, right? You have these two angles, alpha and beta. So you see here again, I'm applying what we already know. The sine of alpha is equal to a over c, and the cosine of alpha equal b over c, and the tangent a over b. Then we apply the same here. The sine of beta is b over c, the cosine is a over c, and the tangent is b over a. So you can see that the sine of alpha is equal to the cosine of beta. The cosine of alpha is equal to the sine of beta, and the tangent of alpha is the inverse of the tangent of beta. So that's one of the things they have, and they complementary. They have in common that alpha plus beta has to be 90, because all the angles of a triangle, they have to be 180, right? We know this one, that it has to be 90, so the relation between alpha and beta is alpha plus beta has to be 90 degrees, or pi over 2. Okay, you can try with your calculators and see with 60 and 30 degrees, see what happens. Okay, this is another important rule that we are going to need. Okay, so now in our physics problems, how do we use this trigonometry thing? Well, we use it for especially when we're dealing with vectors. Okay, so we have this vector here, so like typically it's like the speed, then we have an angle, so we can get the coordinates or the components, like if this is the x-axis and this is the y-axis, we call bx equals b cosine, because it's this angle, and this is cosine, and by v times sine. Sine is this part, which is the same as this one. Okay, so it's the y, and then so the vector v is going to be equal vxi, which is this is the unitary vector. I talked about this many times. Unitary vector in the direction of the x-axis, and plus byj, which is the unitary vector in the y-axis. Or you can write it down like this. Okay, so in here you have four magnitude, or whatever you want to call it. You have b, you have theta, by, and bx. Knowing two of them, you can get the other two. Okay, if they give you by and bx, to obtain b, the magnitude is equals square root of bx squared plus by squared, and the angle is equals the tangent of by bx. Okay, if they give you by and the angle, for example, like you have by and the angle, so you know that the sine of phi is equal by v, right? So v equals y over sine of theta. Then here you get v, and then you know that the vx is v cosine of theta. Okay, so it's always like that. So you're going to do exercise about this, and this has to be clear. Okay, now in other places we use a lot of this trigonometry, is when we do with inclines, right? In the inclines you have this is the 90 degrees, and we have the incline with an angle. We always say that we have the gravity acting here. The gravity goes straight down, it's perpendicular to the ground. Now usually we define what is the x like here and the y-axis in here. We define it like this. Okay, so this gravity is going to have a component in this x-axis and the component in the y-axis. What are those components? Well, you're going to have this angle, so this angle is the same as this, because this is perpendicular to this line, and this one is perpendicular to the ground, and these two lines, they form this angle, so they're perpendiculars, they also form the same angle. Another way to see it is like you can compute this guy, maybe let's call it alpha, and you know that alpha is equal 90 minus theta, right? Okay, sorry, this one lag. So minus theta, so this one and this one, so what is this? This is 90 minus alpha. This 90 minus alpha, which is theta. Okay, so that's another way to say it. Anyway, so usually here we have this component. So what is this going to be? Fgx is equal Fg, which is this, so it's sine of theta. Look, that is, you can also say cosine of alpha, okay, which is this one. Or sorry, this one, maybe better, this alpha. Okay, and Fgy equals Fg cosine of theta. It's this one and this. Okay, and you have everything in here. You have everything in the y-axis and the x-axis. Now this Fy usually is the same as the normal, and this is what produces the acceleration going down. And sometimes you have the friction in here, which is supposed to be in the x-axis, if I draw it right, and that's how it works. Now when okay, let's see, so when you have the car taking the curve, like this is the curve is taking the curve, okay, you have Fg theta, and now we are using x and y like this, so and the normal is perpendicular to here, and it has this angle, which is this is perpendicular to this to this line, and this is perpendicular to this, so both, again, these two form this angle, they're perpendicular, form this angle too. Okay, so now you can decompose. This is the x and this is the y, and Fn in the y is Fn cosine of theta, and Fn in the x is Fn sine of theta. Okay, the same. Okay. Okay, so I think this is everything I need to show you about this trigonometry and how to apply it. And well, if you don't understand, just let me know. I'm going to send you some exercise. I'm going to give you some links in the comments in the description of this video, so you can practice. Okay, so yeah, I hope everything's okay and you understand everything. Okay, see you in class. Bye.